But it can't all be just about pluses and minuses. We need some other numbers as well. And so we do need a way to calculate a change in entropy. And so changes in entropy, good news is the calculation looks a lot like the enthalpy of formation equation for the enthalpy. So it's the sum of the entropy for the products minus the sum of the entropy for the reactants. And we do use the balancing coefficients, so the stoichiometric coefficients as well. And these numbers are given to you in the back of the book as well. And so that's where you're going to have to go to find them for the most part. And it's in that Appendix A3, I believe, Appendix 3. So in our first example, let's calculate the change in entropy for nitrogen gas added to oxygen gas forming N2O4. But before we do that, let's predict the sign. Do we think this is going to be a negative change in entropy or a positive change in entropy? Well, if we think back to what we know about changes in entropy, we see that we are going from 3 moles of gas on that side, so we have a total of 3 moles, and we're going down to just 1 mole of gas. So would this system become more organized or less organized? It's becoming more organized. We're going from a state of disorder with 3 gases to a state of disorder with only 1 gas, though. And so a delta S that has more order is going to be a negative value. And so we're going to have a negative entropy. At least that's what we think. Let's find out, though. Alright, so you can look these numbers up. I went ahead and looked them up. 191.5 for nitrogen, 205 for oxygen, and 304.2 for dinitrogen tetraoxide. And the units for all of those are joules per Kelvin mole. So we take those numbers and we plug them in, keeping in mind that it is products minus reactants. So we've got our products first, then we subtract it from our reactants, and since there is 2 of the oxygens, it's 2 times 205. Standard enthalpy would end up being a negative, as we predicted, 297.3 joules per mole Kelvin. So that's actually a good habit to get into, is predicting the sign before you do the equation. What that does is it first gives you practice with predicting signs, something you're going to need to be very good at it, but it also helps you kind of check your answer. So if we would have gotten a positive number here, maybe we'd need to go back and check something.